All right, last one. Question 6 to 10. So we're looking at a bunch of different curves, and we want to know in question 6, where is the derivative negative and the second derivative negative as well? So when is the function decreasing, and when is it concave down at the same time? So we have to be looking at curves that are strictly decreasing. So if we look at A starts off increasing, so it's not strictly decreasing. B is decreasing, but if we look at the graph of B, it is decreasing, but it's concave up, so the second derivative would be positive. C is an increasing function, so that's out. D is an increasing function, so that's out. And E is a decreasing function, and it is concave down. So E is where the first derivative and the second derivative is negative. For B, or for 7 rather, we're looking at second derivative positive, so concave up. First derivative negative, it has to be going down. Again, A starts off increasing, so that's out. B is decreasing, and it is concave up. So B would have a positive second derivative and a negative first derivative. If we have a point of inflection, then the second derivative is equal to 0 and changes signs. So the second derivative has to equal 0, and we have to have a sign change. So let's find those places where the second derivative is equal to 0. So f prime of x is equal to 15x to the fourth minus 20x cubed. The second derivative, 60x cubed minus 60x squared. When is this going to equal to 0? Well, if we factor out a 60x squared, we'll be left with x minus 1, and that is going to equal 0. So we're looking at the second derivative, and that is going to equal 0 when x is 0 and when x is 1. All right. We now need to pick any x value that is not 0 or 1. Let's say 2. And what is the second derivative at 2? Well, 60 times 2 squared is a positive number. 2 minus 1 is a positive number. And again, I'm plugging them into the second derivative. So 60 times 2 squared is positive, 2 minus 1 is positive. So the second derivative at 2 is going to be positive. Where did 1 come from? 1 came from this factor. This factor has an odd exponent, so there is going to be a sign change. 0 came from 60x squared. This exponent is even. So since this exponent is even, there is not going to be a sign change. This function has a point of inflection when x is equal to 1 because there has to be a sign change. The second derivative doesn't change signs at 0, so that is not a point of inflection. It does change signs at 1, so there is a point of inflection. Hey guys, so yeah, there's a little bit of a typo here, so I had to take a quick pause. This should be a 3. So if we want to write the equation of a line, we need a point and we need a slope. Well, the point that we have to find is the point of inflection. So we know that at the point of inflection, the second derivative is equal to 0. So let's find that x value where the second derivative is equal to 0. So what is f prime of x? Well, f prime of x is 3x squared plus 6x. The second derivative that is a terrible 6. And we want to know when is that equal to 0. So when does 6x equal negative 6? When x is equal to negative 1. So our x value is negative 1. The two things that we need to write the equation of a line are a point and a slope. So we know the x value, and we want to find the y value. The y value is going to be what we get when we go back to our original function f. So what is f of negative 1? Negative 1 cubed plus 3 times negative 1 squared plus 2, negative 1 plus 3 plus 2 is 4. And we need a slope. The slope comes from the derivative. So what is f prime of negative 1? 3 times negative 1 squared plus 6 times negative 1. 3 minus 6 is negative 3. So our point is negative 1, 4, and our slope is negative 3. So the equation of our line, y minus y1, is equal to m times x minus x1. Y minus 4 is equal to m, and then x minus negative 1 plus 1. So there's the equation of our line. And we had to use all three, the function, the first derivative, and the second derivative. So that's a pretty good question because it makes you tie in all of those together. And it also makes you have to understand what does the function do, what does the derivative do, and what does the second derivative do. All right, last one. Why are you doing these things? So we're told that we have a point of inflection at 1, negative 6. And what do we know about a point of inflection? We know that the second derivative is equal to 0. So f double prime is equal to 0 at an x value of 1. So let's take the first derivative. So a and b are constants, so the derivative of ax squared is going to be 2ax, and the derivative of bx is going to be b. Then when we go to find the second derivative, we have 20x to the fourth plus 2a, and then the derivative of a constant is 0, so the derivative of b is going to be 0, so b is going to go away for the second derivative. Now, we know that the second derivative is equal to 0 when x is equal to 1. So when x is equal to 1, 20 times 1 to the fourth plus 2a, this second derivative is equal to 0. So a is equal to negative 10. What else do we know that would help us solve for b? We know that f of 1 is equal to negative 6. So when we plug in 1 into the function, the output, the y value, is negative 6. So let's plug in 1. So we would have 1 to the fifth. We just learned that a is equal to negative 10. Minus 10 times 1 squared plus b times 1 minus 4 is equal to 6. So when we plug in 1 for x into our function, the output value is negative 6. Let's do out this algebra. So we have 1 to the 5th is 1, minus 10 times 1 squared is 10, plus b minus 4 is equal to negative 6. Let's combine like terms. So 1 minus 10 minus 4, negative 13 plus b is equal to negative 6. Add 13 to both sides. b is equal to 7. So a is equal to negative 10 and b is equal to 7. All right, guys, hope these were helpful. I'll see you guys when I see you. Have a great weekend if I don't see you before that. And let me know if you have any questions.